In this section, we're going to continue working with systems of equations, but here you can see that we're going to be working with systems that have three equations rather than just two equations. The concept's the same. It becomes a little bit more abstract to visualize what it would be like for three equations to be coming together and meeting, because now we're not only dealing with an xy coordinate plane, but we're also dealing with what we call a z coordinate plane. So we're dealing with three planes. You can look on page 178 in your textbook, and they give you a really nice visual of how these three planes come together, how they intersect to give solutions that either satisfy all three of the equations with one point, or they could have an infinite number of solutions, just like with two equations. And then they also give you a good visual of what would happen in an intersection of three planes that would give you no solutions that are common to all three. So just like in two equations, we're looking for a solution that's common to both. In when we have three equations, we're looking for a solution that is common to all three of them. So it's the same concept. The most challenging aspect of this lesson is not the concept, because it's essentially the same. It's staying organized enough so that you don't make careless errors when you are working through these problems. That's going to be your biggest challenge, is to not make careless errors. So I want you to pause the video and pull out a piece of lined paper. Don't try to do all the work on this worksheet. You're really going to need a separate sheet of paper for everything we're going to do in this lesson. So pull out a piece of lined paper and rewrite those equations from number 1 onto the lined paper so that you can work over there. And then start the video back up and we'll continue from there. Now, in order to tell whether the given ordered triple is a solution of the system, we first have to make sure we identify our variables correctly. When you have an ordered pair that has three different coordinates, the first one is x, the second one is y, and the third one is your z. So we're going to take those three and we're going to drop them in for each of these equations over here that we just rewrote. So my x is 2. I'm just going to write it underneath here. My y is 1. My z is 3. Okay, so I'm doing 2 times 2, 4, minus 1, plus 15 equals 16. And when we combine those, this is the same. You're doing this the same way you would if there were only two equations. You're going to get 18 equals 16. We know that that is not true. So right here, right away, we know that this ordered triple is not going to work for this system of equations. Because in order for it to work, it has to be true that 2, 1, 3 has to make a true statement and be a solution for each of these equations. So right off the bat, we know that this is not going to be a solution for this system. So that we can write not a solution. We're going to go ahead and try number 4 together as well. So do the same thing, pause the video, and on your piece of lined paper, write those equations out and then start the video back up, and we'll work through that one. All right, so we've got our x, y, and our z. I'm going to drop them in over here. We end up with 4 minus 2 plus 9 equals 11, and we end up with 11 equals 11, which that is true, that does check out. So that 1, negative 1, 3 is a solution for the first equation. Try it again for the second one. Okay. 1 plus 2 plus 3 does equal 6, so again, that checks out as well. All right, and then last one. 2 times 1 is 2, minus 1, plus that 2 times 3, which is 6. And again, we end up with 7 equals 7. That is a true statement. So this is this triple, 1, comma, negative 1, comma, 3, is a solution for all three of these equations. So that means that it is a solution for this system of equations. Now, on the bottom, they ask us to solve the system using any algebraic method. So we could graph, we could substitute, we could eliminate. We're going to do elimination on number 7, and then I'll show you substitution on number 9. So on number 7, we're going to have a few steps that have to be worked through. And again, you want to do all of this on a sheet of lined paper. Staying organized with this is going to be the key for success. So we have to take two of those equations. We're going to take the top two equations, and we're going to use those two equations to eliminate one of our variables. And I'm going to eliminate y when I do that. Right now, in order to use elimination with these two equations, I know that I'm going to need to take one of them and change this y. I'm going to try to eliminate the y's here. That's easiest to do because I can just multiply the bottom by negative 1. So if I take this whole thing and multiply it by negative 1, then we get that new equation out. And then I'll just rewrite, hang on. I rewrite it. I don't have any x's on the bottom, so I need to make sure I'm lining up correctly. Just rewrite that top one. All right, then when I add these together, that's going to eliminate my y's, and I'll end up with x minus 3z equals negative 19. Okay, so I just used those two to eliminate one of the variables, the y variable. So this is my new equation. We're going to call it new equation number 1. All right, now I'm going to do this whole thing again, but now I'm going to use the equation 1, the original equation 1 over here, and I'm going to add it to equation 3. And I'm going to do the same thing. I'm going to work to eliminate y. All right, so the important thing here is that I'm eliminating the same variable I did in the first one. I eliminated the y. If I want to eliminate the y here, I can do a couple things, but I'm going to just multiply the top by a negative 4. All right, and then after I've done that, I'll just rewrite that bottom equation. I'm going to combine them, and I can see that my y's are going to be eliminated, which is what I wanted. And I'll end up with this. Now this is my new equation. We're going to call it new equation number 2. Okay, so what we've essentially done in step 1 and step 2 is use those three equations to eliminate the same variable out of both. Okay, we could have chosen a different variable. I mean, you could do this problem and it could look completely different from the way I've done it, but the whole idea behind it is you have to work with those three equations, adding them up in different ways in order to get two new equations that have the same variable eliminated. So that brings us to the next step then. So step number 3 is going to involve these two new equations. I'm going to take the new equation number 1, and I'm going to add to that the new equation number 2 with the whole goal in mind of now eliminating another variable. And in that way, I will be able to actually solve for one of them. So I'm going to take that first equation up there and set it on top of the second one. And I'm going to look at it, and I'm going to decide that I'm going to eliminate the x and solve for the actual value of z. All right, so in order to do that, I'm going to need to multiply the top equation by 4. course, there's other ways to do this, but this is how I'm going to do it. Okay, I'll just pull the bottom equation over. And now I'm going to eliminate the x's and solve for z. All right, so we see that z equals -8. So now we have our z. So that takes us back up to either the original equations that we had over here or the new equations. What we're looking for is we're looking for an equation that only has two variables that we can substitute z in order to calculate and out the other variable. Okay, so I actually have several options. I've got both of the new equations that I came up with have an x and a z only. They don't have the y in it, so I could pick one of those. Or I could come up here. I've got two equations, original equations. Number 2 and number 3 original equation both have the x missing. So I could solve for solve for y by evaluating z up there. I'm going to choose that. That's what I'm going to do. I'm going to say for my step number 4, I'll just write it over here. I'm going to evaluate for y. Okay, I'm going to choose equation number 2 up there. Again, there's no reason you have to choose that. That's just the one that I'm going to pick. So I'm going to take my z from over here that I calculated and got a -8, and I'm going to plug that in for z. All right, so when I do that, I get a y of -2. So now I have my z of -8, I have my y of -2, I just need to find my x. Let me point out right here that had I chosen that first equation, the first original equation that has 3 variables in it, and I had plugged z of -8 in for that, I would not have been able to solve for y because I've got an x in there as well. So that's why you're choosing an equation that only has 2 variables in it, because then you can actually solve for the second variable by evaluating in at that value of that first variable. So, but now I can use that original equation, that x plus y minus 5z equals -5. So for my final step, I'm going to pick that one at the top because it has the x in it, which is what I need to solve for. Okay. I'm going to leave that x open. I'm going to plug in that -2 I solved for, and then evaluate at z of -8. And I will get an x of -43 when I do that. Now, I also could have just taken the z of -8 and plugged it back up into one of the new equations, because the new equations have the x variable, but they only have a z variable along with it. They don't have the y. So I could have used those two as well to solve for x. So there's a lot of different ways to do this, but this is the final answer. The way you want to write it out in coordinate form would be to put your x first, then your y, and then your z. And so it would look just like that for your final answer. Now we're going to skip over 8 just for time's sake and look at number 9. We're going to do number 9 via substitution instead of elimination. So just like in a set of 2 equations, you can use either one. You can do the same thing with a set of 3. So we're going to look at those 3 equations. I'm going to choose one that I want to solve for one single variable. And it could be any of the variables. I'm going to pick that's the second equation here. So I'm going to pick number 2. And I'm going to solve for my first step. And again, this is, make sure you recognize that now we're substituting. We did elimination on number 7. These would be the steps for substitution. I'm going to just take that second equation there, and I'm going to solve for y. I could solve for any of those variables. I'm just picking y, and I'm going to Actually, I'm going to use that first equation instead, not that second one. Okay, so once I've done that, I've solved for y. It's going to look like that right there. I'm going to move on to step number 2, which is substituting what I just solved for in for one of the other original equations. So I solved for y in the top equation. I'm going to substitute it in for number 2 at y. So right here where it says 2x minus y, instead of writing in y, I'm going to put in this, what I solved for right here in equation 1. Okay, so I'm just going to drop that in right there instead of writing, actually that's right. Okay, so 2x minus y, so I'm subbing it in for this y right here. And then minus 2z equals negative 12. Okay, then I'm going to go through and do that distributing of that negative sign, which is just going to change all of the signs of what's inside that parentheses. All right, once I do my combining, and then okay, I'll end up with this right here. I'm actually just going to go through and multiply everything through by negative 1, just so that then I'm dealing with all positives. If I multiply this equation right here through by negative 1, it just is going to change the sign on everything, and it just looks a little bit less scary to work with because we got rid of some of those negative signs. All right, so here's your new equation number 1. All right, I'm going to do the same thing in step 3, except now I'm going to substitute in what I solved for in 1 on solve for y on step number 1. I'm going to do it on equation 3 down here. So I used 1 to solve for a single variable. I substituted that into equation 2 in order to eliminate the y. And now I'm going to do the same thing. I want to eliminate the y out of number 3 as well. So 4x plus 2, instead of writing y in, so I'm up here at this third equation, instead of writing in y, I'm going to write in that negative 2 plus 3x plus z that I solved for in step number 1 up there. Okay, I've got a plus z equals 1. All right, and distributing that 2. And then combine and take that constant of negative 4 to the other side, add 4 to both sides, and I'll end up with this right here. So there's my second new equation. Again, with the same variable eliminated out that I did in equation number 1. Whoop, that should say number 2. Okay, so the y's are missing in both of those, which is good. That's what we wanted. All right, so then the next step, for step 4, I'm going to take both of those new equations and I'm going to combine them. So we're going to say new equation number 1 plus new equation number 2. Okay, so essentially now we're going to take those two, combine them together so that we can solve for one of the variables. So this step becomes an elimination step. All right, when I combine those, I'm going to multiply the top line through by negative 1. All right, rewrite the bottom equation, and then this is going to eliminate the z out. So I'm going to end up with 9x equals negative 9, which means x is going to equal negative 1. All right, so now I've got my x solved for. I'm going to go into both of those new equations, and I'm going to use those to solve for the other variables. So I'm going to plug negative 1 in to this top new equation here. It doesn't matter which one I pick, that's just the one I'm going to choose. All right, so step number 5. I'm going to use that new equation, number 1 there. Put x of -1 in, and then I'm going to solve for z. And when I do that, I will get a z of 5. So now I have x, I have z. I have several choices for what I want to do next, but I'm going to choose, all I need now is an equation with all 3 of those variables in it. So I'm going to pick, let's see, I think it's that first, yeah, that top equation, the top original equation, which looked like this. And I'm going to substitute in my x I solved for. I'm going to leave the y open because that's what I'm going to solve for now. Okay, and then when all is said and done, I think I skipped a line there. My y is going to equal 0. All right, and then for the final step, you just write it out as a triple, -1, 0, 5, and that is your final answer.